Dear students, let us start with the 2-mark questions. So the first taken will take a 50 diameter disc is to be punched out from the carbon steel sheet 1 millimeter thick. The diameter of the die should be, take the clearance as 3% of sheet thickness. So here they are saying that the diameter of the disc is 50 which is punched from a sheet of thickness 1.0 and the clearance is how much? 3% of sheet thickness, isn't it? So option A 49.925, option B 50.00, option C 50.075, and option D none of the above. So all are in millimeter. Okay, so students, please focus on the question. What they are saying, they are saying that a 50 millimeter diameter disc is to be punched. So what they are going to produce? A disc, that is the produced slug or the produced blank is useful for us, that is the operation is blanking operation. And you know that in blanking operation the diameter or size of the die is equal to size of the or diameter of the disc, isn't it? So here the same thing they are asking for the diameter of the die. So diameter of the die, say D is equal to, what is the diameter of the disc? Is 50 millimeter. So 50.00 millimeter is the diameter of the die. And where to provide the clearance? On the punch. So punch size becomes smaller than that. So 50 minus 2 times clearance is how much? 3% of sheet thickness, that is 1, isn't it? So 50 minus 6 by 3, sorry, 6 by 100, 6 by 100, 50 minus answer 49.94. okay, so 49.94 will be the size of punch. Okay, so definitely in blanking operation we are providing the clearance on punch and die diameter should be as equal to the blank diameter. So 50 is the correct answer for this question. Let us take the next question for 2 mark. Identify the stress strain in the flange portion of a partially drawn cylindrical cup when deep drawing without a blank holder. Okay, so this is the partially drawn cup. They are saying, say the punch has moved in the die and now the deformation is going on. Okay, so bottom of the punch 1, deformation zone 2 and flange portion 3. We already discussed this. The stresses induced for the partially drawn cup with and without blank holding pressure or force. Okay, so we know that at the flange portion, that is at this zone 3 flange portion without BHF, we know that there will be 2 directional tensile. Okay, 2 directional tensile and compressive in 3rd direction. Okay, because at the flange portion these wrinkles are going to have like this. So 2 directional or the tensile and compressive in 3rd direction. These are the stresses induced in the flange portion. So option A, tensile in all 3 direction. No stresses in the flange at all. No. Tensile stress in one direction, compressive stress in other direction. No. Tensile in 2 direction and compressive in 3rd direction. That is the answer. We already discussed this. Next question. A shell of 100 mm diameter and 100 mm height with the corner radius 0.4 millimeter is to be produced by the cup drawing, the required blank diameter is. Okay, so here the cup diameter is 100 millimeter and height of the cup is 100 millimeter. Corner radius is how much given? R is equal to 0.4. Diameter of cup is 100, height of the cup is 100. Isn't it? So let us check first what is D by R. So D is 100 divided by R. So it is more than 20. No issue, isn't it? So you can have the blank size equal to under root of D square plus 4 DH. What is diameter of this cup? 100 square plus 4 times 100 times 100. So D will be calculate this. 4 e to the power 4 plus 100 square root of the answer. So it is 223.60 millimeter. So this is the blank size. Okay. So options are 118, 161, 224 and 312. So 224 is correct answer. Clear? I hope it is clear now. Next question I am reading now. 10 millimeter diameter hole are to be punched in a steel sheet of 3 millimeter thickness. Shear strength of the material is 400 megapascal and penetration is 40%. The shear provided on the punch is 2 millimeter. The blanking force during the operation. Okay. So of course you can have the blanking force. Once the shear is provided, you are going to calculate the force with the provision of shear, that is FB. Yes or no? I don't know FB is what? F max KT divided by KT plus I. Okay. So here you should calculate F max, that is pi d tau pi dt into tau into KT divided by KT plus I. Very simple. So what is diameter is to be punched? 10 mm hole. So that is 10 pi times thickness is how much? 3 millimeter. Penetration 40%. Thickness is 3 millimeter divided by 0.4 into 3 plus how much shear is going to provide? 2 millimeter shear they are going to provide. So I have a calculation for this. So 90 pi into 0.4 divided by 3.2. Okay, here we have forgot to multiply with the shear strength. So how much shear strength is given? 400. Okay, so it is 400 here. So 10 pi into 3 into 0.4 into 3 into 400 divided by, this will be 1.2, that is 3.2. So it is how much? 14.1 kilonewton. The F is how much? 14.1 kilonewton. That is the force after provision of the shear. Okay. Next question. A 2 millimeter thick metal sheet is to be bent. The diagram is given like this. This is given as 1 radian. Thickness of the sheet given as 2 millimeter. The question is, a 2 millimeter thick metal sheet is to be bent in an angle of 1 radian with the bend radius how much? This bend radius is given as 100 mm. Okay. If the stretch factor is 0.5, the bend allowance is stretch factor, that is bend factor given as K is equal to 0.5. They are asking the bend allowance. How to calculate bend allowance? We know the formula. Bend allowance is equal to alpha into R plus KT, where alpha should be in radian. So it is given in radian only. 1 into bracket R 100 mm plus K 0.5 times thickness 2 mm. So 100 plus 1, that is 101 millimeter. Bend allowance will be how much? This bend allowance will be how much? 101 millimeter. Bend allowance will be 101 millimeter. So that is correct answer. This is IIT Bombay question from 2005 paper, 2 marks. Next we are having the match the pair for the defects. Okay, very simple. I will just read it. Wrinkling, it is why the wrinkling is going to happen? Because of insufficient blank holding force, that is given in the another column. Orange peel, this is the what? Large grain size, it is also given. So very easy. Next question, the force requirement in a blanking operation of a low carbon steel sheet is 5 kN. So force requirement, how much given? F max. For the same work material, if the diameter of the blank part is increased to 1.5 d. Now for the second case, what they are saying, the D2 will be 1.5 d and the T2 will be 0.4 times T1. Say this is T is equal to T1 and D is equal to D1, and this is F max 1. So what they are asking, what is F max 2 will be how much in the second case? So very easy. See, we know that this F max is equal to what? What? Pi d t, isn't it? So F max is proportional to this d into t. So we can write F max 2 divided by F max 1 is equal to what? D2 into T2 divided by D1 into T1. So what is D2 diameter कितना बढ़ाया? It will be 1.5 times D1 and thickness कितनी घटाई? 60%, that is 0.4 times T1, D1 into T1. So F max 2 will be how much? F max 1 is how much? 5 kilonewton. So 5 into 6. So it will be how much? 30 kilonewton. F max 2 will be how much? Oh, see the options. Diameter is become 1.5 d and thickness is reduced to 0.4 t. So what is the answer? 5 kilonewton is there. So 1.5 into 0.4. It is 0.6, no? 0.6. So it will be 3 kilonewton. Yes, 3 kilonewton is the answer. So options are 3 kilonewton, 4.5 kilonewton, 5 kilonewton and 8 kilonewton. So 3 kilonewton is the correct answer. Next question, again very simple questions are there. Calculate the smallest punch diameter that can be designed for piercing sheet with the following data. Okay, so what is given? Crushing strength of the punch material, sigma c is given as 1500 megapascal. Thickness of the sheet 2 millimeter. Factor of safety 3, and the shear strength of the material 500 megapascal. And what they are asking, what is the minimum diameter can be punched? Okay, so we know that how to calculate this. D minimum, so sigma c into pi by 4, d square is equal to, this is the reaction offered by the sheet onto the bottom of the punch. Okay, that is this punch cross section area pi by 4 d square into sigma c is the crushing strength of the punch material, is equal to F max, which is pi dt. So pi get cancelled, d here get cancelled. So d minimum will be what? 4 times t times tau divided by sigma c. So here factor of safety given. So I told you where to take this factor of safety, always on punch material. So sigma c will be how much? Sigma c allowable 1500 divided by 3, that is 500 megapascal. You put the values, d minimum will be equal to 4 times thickness is 2 times shear strength is 500 divided by sigma c is 500. So d minimum will be how much? 8 millimeter. D minimum will be how much? 8 millimeter. Let us take the next question. In sheet metal working, the spring back increases when? Next statement, R, that is sigma y is high, and yes, tension is applied during bending. Tension is applied during bending. So what they are asking, in the sheet metal working, the spring back increase when the spring edge going to increase. So these are the 4 statements are given, and you have to choose the correct statement out of this. Okay, so you know that what is spring back is R final divided by R initial is equal to what? 4 times Ri divided by Et into sigma y whole cube minus 4 times Ri divided by Et into sigma y minus 3, no? Minus 3 times Ri divided by Et into sigma y plus 1. So Rf divided by Ri is proportional to the Ri by T. It is proportional to the yield strength of the material, and it is inversely proportional to the modulus of elasticity. Isn't it? So here, when the spring back increases, they are asking. So when it will increase? So when this is high, and this is low. So which are the statements are correct there? To increase the spring back, so we need Ri by T should be high, so this is not the correct statement. Tension is applied during the bend, this is also not correct. So sigma y high, yes, sigma y high, and modulus of elasticity should be low. So Q and R are the correct statements, isn't it? Q and R are the correct statements for the spring back, we know that. This was 2 mark question from IISc Bangalore for 2003. Next question. A cylindrical cup of 48.5 millimeter diameter. Cylindrical cup 48.5 millimeter diameter and height 52 mm has a corner radius is equal to 1.5 mm is used to produce the cup. Assume trimming allowance is equal to 2 millimeter per 25 mm of cup diameter. What is the blank size? D total is equal to how much? Option A 102.0, 115.4, 120.5 and option D 128.5. See, so trimming allowance, what is the thumb rule? I already taught you, that is actually this is 3 millimeter on 25 millimeter of cup diameter. Okay, it is given on the blank size. So first of all, calculate the blank size. D is equal to under root of D square plus 4DH. Let us check first what D by R ratio. What is diameter? 48.5 divided by corner radius 1.5. So whether it is greater than 20 or not, we have to check now. So 48.5 divided by 1.5, how much? It is 32.3, which is greater than 20, isn't it? So no need to subtract the corner radius or half of the corner radius from this obtained blank size. So it is equal to what? Diameter 48.5 whole square plus 4 into 48.5 into height is how much? 52. Calculate. कितना आता है देखो? That is 48.5 into 52 into 4 plus 48.5 square root of the answer. So it is coming as, blank size is coming as 111.53. Okay, so this is the blank size. But here now, dear students, trimming allowance is provided. What is trimming allowance? So trimming allowance is provided as 2 millimeter for 2 millimeter on the 25 millimeter of cup diameter. What is cup diameter? They are asking for cup diameter कितना चाहिए आपने को? 48.5 mm. So how much? 2 divided by 25 into 48.5. So it should be equal to 3.8. So this is the trimming allowance. Now what is the diameter total? By including this trimming allowance, what is the blank size? 111.53 plus this trimming allowance 3.8. Calculate. Plus 111.53. So 115.41. 115.41 millimeter. So D total will be how much? 115.41. So I hope the B is the correct answer. Okay, very easy. I have taken the example also during teaching this trimming allowance. Okay, next question. See, a hole of 40 millimeter diameter is pierced in the steel sheet of 4 mm thickness without shear on the tool. So initially a hole of 40 mm produced on thickness of sheet 4 millimeter without shear. Okay, so in this case no shear is provided and they are giving us the shear strength of the material 400 Newton per mm square. Okay, and at the same time they are saying penetration is 25%. Okay, what is the expected percentage load reduction if a shear of 1 millimeter is provided on the punch? So I is how much? They are saying it is 1 millimeter. So what will be the reduction in load they are asking? Okay, so let us calculate first F max, then we will calculate the force without shear, then force with the shear, and whatever the reduction we can get it easily. So F max we know pi dt tau s. So pi times diameter कितना चाहिए? 40 मिलीमीटर into thickness कितनी है? 4 मिलीमीटर और shear strength कितनी है? 400 megapascal. So what is the load here? 160 into 400 pi. It is around 201 kilonewton. Okay, so no any shear is provided in this case. Now shear is 1 millimeter they are going to provide on the punch. So tell me what is the FB now? It is F max 25%, that is 0.25 into thickness of sheet 4 millimeter divided by K 0.25 into thickness 4 plus shear 1 millimeter. So this is 1 plus 1 2. So 201 into 0.25 into 4 divided by 2. So it is 120 100.5 kilonewton. So simply you can say what is the percentage reduction in the load. पहले लोड कितना था 201 था, अब कितना हो गया आफ्टर प्रोविजन ऑफ शियर 100.5. सो कितना हो गया डायरेक्टली यू कैन हैव दी 200 से 100 आ गया, दैट 201 से 100.5 आ गया, तो कितना हो गया 50% लोड रिडक्शन यू गॉट हियर. ओके, सो आई होप 50% इज गिवन इन द ऑप्शन. So option A 25%, option B 33.33%, option C 50%, and option D 66.67%. So you got it, 50%, that is the correct answer. Next, the question is 525 mm hole is pierced in a thickness 2.5 millimeter thick sheet having the shear strength as 350 megapascals. If the diametral clearance is given by the expression C is equal to 0.0064 times T under root of tau in millimeter, they are asking what is the size of the die, size of the punch and the force in the operation. Okay, so this is the punching operation. So definitely punch size equal to how much? Punch size will be equal to hole size, and we are going to provide the clearance on the die. So die size equal to what? This punch size plus 2 times the clearance. Okay, now as it is, see, the clearance is directly diametral clearance is given. We know this is the optimum clearance. So calculate this 2C value directly here. 0.0064 times thickness is 2.5 millimeter into root of 350. So what is the value for clearance? Root of 350 into 2.5 into 0.0064. So it is 0.299. okay, so I will take it as directly 0.3 millimeter. Okay, so what is die size now? Punch size we got it as directly 25 millimeter only because this is the punching operation, and die size will be punch size minus 2 times clearance, that is 2 times clearance is already there. It's a diametral clearance, it's a diametral. We know the formula 0.0032 times thickness root of tau, which is the radial clearance. Which is the radial clearance. Then we have to multiply by 2. So directly it is given. So 25 minus this answer 24.7 millimeter. This will be the die size. And what is the force? F max will be pi dt into tau s. So pi into diameter 25 mm into thickness 2.5 into ultimate shear strength 350 megapascal. So calculate this. 350 into 2.5 into 25 pi. So it will be 68.72 kilo Newton. The F max will be this. So these are the 3 bits they are asking. This is the first, this is second, and this is the third. Okay, so these are the answers for the question. Let us go for next question. A cup is drawn to a diameter of 70 millimeter with 35 millimeter depth from a 0.5 mm thick sheet metal. The cup is drawn in one operation. Assume ultimate strength of the material is 430 megapascal. They are asking the required blank diameter and maximum drawing force. Let us solve. So again, this is a question on deep drawing operation. See, a cup is to be drawn to a diameter of the cup is how much? 70 millimeter, and it is depth, that is height, is equal to 35 millimeter, diameter 70 millimeter and depth 35 millimeter. So this is the depth, that is height 35 mm and diameter is how much? 70 mm. And thickness of the sheet is 0.5 mm. Ultimate strength is given, that is 430 megapascal. Dear students, I already thought about this whenever in the deep drawing operation. Many times they are trying to give the ultimate strength or tensile strength, but we need the yield strength. Please remember. So you should calculate the yield strength, what? 430 by 2. That is 215, isn't it? Megapascal. Very important thing. Okay. The required blank diameter. So blank diameter, no any corner radius is given. So no need to worry about d by r. So it is equal to under root of diameter is how much? 70 square plus 4 times 70 times depth 35. So blank diameter you can calculate. That is 280 into 35 plus 70 square. Root of answer, it is 121.24 millimeter. You get the blank size here. And second thing, they are asking the maximum load in the drawing operation, how to calculate. It is equal to pi dt into sigma y into bracket d by d minus c. So nothing is mentioned about clearance, so neglect it. So the small d get cancelled. So pi into capital D into T into sigma y will be the force. So pi into diameter is how much? Blank size how much? That is 121.24 into thickness 0.5 into sigma y 250. Calculate this into pi into 0.5 into 250. So it is 40.9 kilonewton. It is 40.9 kilonewton. So this is the maximum drawing force. So let us check. 121.24, yes, it is in the option, so it is correct. And second thing, it is 0.04. If you want to write in meganewton, then it is how much? So again divided by 1000, you get 0.04 meganewton, isn't it? So that is the correct answer. It is given in the meganewtons. It is given in the meganewton. 0.04 meganewton is the correct answer. Okay. So this is about the deep drawing operation where you have calculated the blank size and the drawing force. Please remember, whenever in the deep drawing numerical ultimate strength is given, you should convert it into yield strength by dividing it by 2. We are generally saying that the yield strength will be the half of the tensile strength or ultimate tensile strength. So see, this is the next question, ME 218. We have to put the answer for the question. So here see, the circular shaped workpiece is going to produce from the given strip of length L and height H. Okay, and of course this is the length L and height H with thickness is something. Okay, and we know this is the front scrap, back scrap and scrap bridge value is given as d by 5, d by 5, and the diameter is how much? Circular blank is d. Okay, so we need to find out what? The scrap. Okay, we know that how to calculate scrap is nothing but 1 minus percentage utilization. We get the percentage of scrap. So let us find out the number of blanks, or directly no need to have this calculation for number of blanks. What is the formula for percentage utilization? We have seen percentage utilization is equal to what? The area of the blank divided by control area, isn't it? The control area. We know what is control area? That is the feed into height, isn't it? So it is area of the blank will be pi by 4 d square, and what is control area? Say this is the control area. This is the control area. That is, this is the advance, nothing but the feed into height, isn't it? That is, S is how much? This d plus d by 5, d plus d by 5 into d plus this d by 5 plus d by 5. Okay, so 2d by 5, isn't it? D plus 2d by 5. So calculate and tell me what is the percentage utilization there. So this is 5d by 5 and this is 5d by 5. So it is equal to pi by 4 d square divided by 5d plus 5d by 5, that is 6d by 5, nahi? 6d by 5 into this 5d plus 7d, 5d plus 2d, that is 7d by 5. So we'll get here 5 by 4 into d square into 25 divided by 42 d square. Okay, so d square get cancelled. This is 25 pi divided by 4 into 42. Calculate. कितना आएगा? 25 pi divided by 4 divided by 42. So it is how much? 0.46. Okay, this is utilization. Okay, but in the question what they are asking, what is the scrap? So scrap will be was then 1 minus this utilization 0.46. It will be 1 minus answer, that is it is 0.5325. That will be nearly equal to 53.25%. If you multiply by 100 to this, in percentage you will get 53.25. So 53.25 will be the scrap, and what is actual utilization? Multiply by 100, you will get 46%. This is the maximum utilization. So, and this is the scrap. So this is based on which? Stock strip layout. So this is how we can able to solve the various questions. Go on solving the questions from the previous year, from the practice books, okay, to get the out of marks in this topic, sheet metal operation. Very easy topic. Out of marks definitely you can get. Thank you.